Alright, this is skill practice 34% yield part 2. I left off by multiplying by the molar mass of aluminum, which was 26.98 grams of aluminum over 1 mole of aluminum, to get the final mass 49.3 grams of aluminum. We then plug that into our percent yield equation. So the actual 38.5 grams of aluminum times the theoretical 49.3 grams of aluminum times 100 to get 78.1% as our percent yield. Okay, question 4. This one's a little tougher because they give you the percent yield and you have to solve for the mass that will be produced. So let's get at it. Consider the reaction in which 370 grams of CaNO3 reacts with just the right amount of lithium metal in a single replacement reaction. If the percent yield of LaNO3 is 74.3%, what mass of LaNO3 will be produced? So first, again, we're going to write out the balanced equation, which is CaNO3 plus 2Li combined to form 2LiNO3 plus Ca. So we work this out pretty much the same way by finding the mass of LaNO3, because that's the one we're trying to find the mass for that was actually produced. Okay. So first we multiply by 370 grams of CaNO3 by its molar mass, which is 1 mole of CaNO3 over 164.1 grams of CaNO3. We then multiply that by the mole-to-mole ratio, which here is a 2-to-1 ratio between LiNO3 and CaNO3. So then we multiply that by the molar mass of LiNO3, which is 68.951 grams per mole, to get 310.9 grams of LiNO3. Now that's our theoretical yield, so we're looking for the actual yield. So we have to plug those values in, the values that we have, into the percent yield equation. So we have the percent yield, which is 74.3%, and that equals the actual yield, which here I made it an X, over the theoretical yield, which is what we just calculated, the 310.9 grams of LiNO3, and we multiply that by 100. So if we solve for the missing variable, which we do by dividing the 74.3 by 100 and then multiplying by the 310.9, we then get the 231 grams of LiNO3. Okay. Question 5. Again, this is just like the other ones, so it shouldn't be too complicated. If 42.4 grams of aluminum react with excess O2 and 67.3 grams of Al2O3 are produced, what was the percent yield of Al2O3? Here they actually give us a balanced equation of 4Al plus 3O2 combined to form 2Al2O3. So we do the same thing, we find the mass of Al2O3, which should be really simple by now. So 42.4 grams, we divide that by the molar mass of aluminum, which is 1 mole of aluminum over 26.98 grams of aluminum. We then multiply by the mole-to-mole ratio, which here they try to make it a little bit complicated, because it's a 2-to-4 ratio here between Al2O3 and Al. That would give us the moles of Al2O3, which we then multiply by the molar mass of Al2O3, which is 101.96 grams per mole, to give us the final mass of Al2O3, which is 80.1 grams of Al2O3. We then plug that into our percent yield equation to get the percent yield. So 67.3 grams of Al2O3, the actual, over the theoretical 80.1 grams of Al2O3 times 100 to get the percent yield of 84%. And that is it for skill practice 34.